Welcome. Thanks everyone for coming this afternoon. My name is Fraser Macdonald. I am a product guy on IoT Cloud at Google.
And I'm John Hurd. I'm CTO at Smart Parking, a company that's using IoT Core.
So thank you all for joining us. We want to ask you a question just to get things rolling here, just to get a bit of a sense of who's joining us this afternoon for the next 45, 50 minutes. So just by some hands, how many in the crowd today are working directly for a municipality? Okay, so we got some hands for people that are working with cities themselves. How about people that are working for vendors that serve municipalities? Okay, so a good number there as well. How about people who have lived in a city? Oh, what do you know? All right, so we've got some subject matter experts here. That's great. And I say that kind of half-kiddingly, but one of the points that John and I want to talk about today is a bit of an idea of who are we building these smart cities for? What is the reason for making them, not just how you make them? So I think everyone in the audience has got a bit of a voice in that. So thanks for joining us. So let's warm up with a bit of a teaser. Take a look at this kind of echocardiogram looking thing off to the side here, and see if you might recognize some patterns in it. Does anyone have any ideas of what we might be looking at? Yep, some urban areas, some parking. They're definitely urban areas, you're right. In fact, if we show the names here, we're looking at some familiar areas. You got the Bay Area off to the side, New York, London, Tokyo, San Francisco. So what we're looking at here is movements of people on their mobile devices. Every one of these dots is somebody that has opted in Google Maps on their phone for location tracking. So you've taken that data, anonymized it, collected it, and you're looking at the living, breathing city here. This is a 24-hour cycle of where people are going, what they're up to, and this is enormously valuable data. It gives us a bit of a sense of context for what we're talking about today, that there's an incredible amount of information that's available to us if we can make use of it. So this is for people's personal uses on their phones and maps and seeing where they've been. But imagine how useful data like this could be to people who are planning traffic patterns, people who are trying to plan pickup routes for waste management, somebody who's trying to get a new freeway going, somebody who's trying to choose where the next neighborhood that businesses should grow in. We're seeing a growth in mobile devices, we're seeing a growth in IoT devices, and we're seeing a simultaneous growth in the ability to process this data on a massive scale. So this is just the beginning of smart cities. We're getting into a really exciting age for it. So question. You might have expected coming to a tech conference, coming to a Google conference, that we're going to talk purely about technology. And is this what smart cities mean, the technologies? So yes and no. Yes, in that these are definitely ingredients of a smart city. I mean, having access to Wi-Fi is what gives us the ability to collect data. Having RFID transit passes are fantastic resources for municipal planners to know when and where are people going so that we can make smarter routes. Having self-driving cars are going to be an enormous overhaul of what it means to live and be transported inside of our cities. But these are ingredients. I mean, in the same way that ingredients alone don't make a cake, this isn't the smart city itself. What John and I want to talk about today is a bit of a shift. And we're wondering if you join us in this shift from thinking about a couple of the nouns, a couple of the technologies of smart cities, to a few adjectives that might describe them. So over the next little bit, we're going to do a few things. One is I'm going to share a few stories of what we've learned at Google from some projects that we've been involved in that overlap with the smart city space. So a bit of stories that we've had some learning from and a bit of what ifs. And then we're going to hear from John. And John's going to tell us, well, if that's the what if, this is what it actually looks like. John and his company are building the kind of infrastructures for cities around the world right now that let them make good use of their data. And we're going to wrap up with a Q&A. So before we dive into some of these stories that we've learned from, I should call out that this session is one in which we have Dory. So you might have been in a session this morning that has Dory as well. It's a Q&A tool that we've got at Google, and we're rolling it out and trying it at this conference. So if you go into the mobile app that you have for this conference and you go to our session, you might notice that there's a Q&A portion in it, where throughout our talk, if you see something that looks interesting or a question crosses your mind, in the moment, you can write a Q&A question, and the rest of your fellow audience members can vote it up. And at the end of the session, we'll mix a bit of microphone questions and Dory questions from our moderator who will read them out. So if a question crosses your mind, feel free to hop onto your app and ask it as we go. Okay, so let's take a look at some stories of what we've learned at Google from some smart city adjacent and overlapping projects. What's the first adjective that comes to mind? The first adjective of smart cities that at least John and I, when we were sitting down to chat about this, thought of was efficient. And I think there's a reason for that is because it comes up the most regularly for smart cities. Take a look at this. This is the list of the most common smart city projects that are underway right now in the world. And if you're taking a look at it, you'll probably notice a bit of a pattern to it as well. You've got parking, street lighting, waste and energy management, and then a whole bunch of transportation, logistics, and optimization. These are efficiency problems. And one part of it might be, yeah, these are the low-hanging fruit. These are areas where an IoT sensor or actuator can really help and not be too complex of a rollout. But another big reason for this is these are areas of high ROI. Each one of these is making the city better able to spend its money or better able to allocate its resources. And a really important adjective of a smart city is one that is not wasteful with its resources. So what does an efficient smart city look like in the project that we've worked on? Some of you might remember this demo from Next 2017. This is a bit of a what if. This is something that we showed, which is taxi cabs driving around a city. So we've got some simulated fleets of taxis across New York. And these taxis are kitted out with something that's a little different. And instead of having just a display ad in the back that's showing you a clip or an ad for something, they're also location aware. They know where they're picking up, where they're headed, what time of day it is. And with just a little bit of that information, we were able to personalize the ads to whoever might be riding in the car with an incredible amount of accuracy. It's a tiny bit of additional data, but it produces a huge outcome. So this is an example for ads, but imagine this kind of intelligence if it were applied to real-time traffic control. If your city, or you're building a tool for a city, was able to equip the city's traffic control measures to respond to floats and parades, to respond to an event that spontaneously happens, to respond to live traffic conditions. Or imagine if this kind of real-time data and a little bit of location and time awareness was able to affect waste collection. So that's exactly this next example. This is a company called Enevo, and they're a Google customer, and they're building something pretty cool, which is a waste management solution. And instead of being the traditional take on waste management, which is usually sort of schedule-oriented, and you know your time when you're going to get a pickup, the truck comes by, they pick up your bin whether it's full or not, and they drive off. Enevo decided that they were going to add some sensors and a bit of an intelligence to the process. So their parking, or rather their waste management solution is aware of how much trash is in the bin. They sell this to companies that need a more efficient pickup schedule, and all they did was put a couple sensors in to know when trash is getting full and slapped a GPS on their trucks. And out of a small change like that, their customers got better service because they had reliable pickup and didn't have to think about scheduling so much as starting to think about waste management as a service. And they themselves got better optimization out of their route because they could tell their drivers exactly where to go and where they were needed. So what's another adjective that might give us a bit of a place to start for smart cities? Participatory. So what would that mean? There are a couple of perspectives you could take on this, and one of them is participation of the people that live in the cities themselves. So here's another project that we had some overlap with at Google. Some of you in the audience might recognize where in the world we are flying over right now. This is Japan. And specifically, this is an image that was captured back in 2011 when in the Fukushima area of Japan, there were 3 nuclear reactors that melted down. And it was a major public safety concern. And there was a pretty incredible response in 2011. What we're looking at here is a couple people in Japan that were citizens put together Geiger counter kits. They were makers and tinkerers and shipped them out to people, other citizens around the country, who got them, built them, connected them up to the web on a platform called PatchBay at the time, and overlaid it on top of Google's Maps. And what you're seeing here is people getting involved in producing and engaging with the data of their own cities to make them smarter. This was real-time intelligence on, should I be in my area? Am I safe? Now, this is an interesting and personal one for me because this platform, PatchBay, went on to become the Xiidley IoT enterprise platform that Google just bought earlier this year and is getting rolled in as part of the IoT Core Cloud offering. The next one here is Sidewalk Labs. You might have heard of this one as a sister company of Google, underneath Alphabet. And Sidewalk has a mandate to not think about the city of next year or 3 years from now. They're thinking about this, what might cities look like 20 or 40 years from now. So this is another project we're involved with that gives a bit of an idea of where might we be headed. And Sidewalk's taken on a really ambitious project. It's another one that's a little bit personal to me. As a Toronto by myself, growing up not too far from that watercolor toothpick on the left there, This is a micro city that Sidewalk's taking on in Toronto. They're going to wire up absolutely everything, from the municipal infrastructure to the transportation to waste management to lighting, and they're going to try to figure out what can we do with the data. So this story is just beginning. The Sidewalk story is just starting. But what would it look like if we wanted to try to affect some of these changes and play with some of these ideas right now? We've done some of these projects as Google. What are some of the tools as GCP that we're rolling out so that we can help companies and municipalities try some of these ideas themselves? So how might I tackle efficiency in a participatory city? Let's take a look at Google Cloud IoT for a minute. So like much of GCP, we're building on the exact same tools and stack that we build on for our own products. When you're looking at the Google Maps infrastructure, you're looking at the same company that's producing GCP tools for your company to use. And we took the same approach with IoT. This is an example of what an infrastructure might look like for powering a smart city project, using a couple of GCP building blocks. So on our left, we've got our devices, whatever they might be. Whether those are occupancy sensors, they're smart energy meters, they are watching out for traffic patterns. These are the devices on the left that have something to say or that might be controlled, like a stoplight. And the tool that we put together in the middle here is Cloud IoT Core. So this is a recent product we've started rolling out specifically for this use case. There are a lot of GCP ingestion tools for huge amounts of data, like PubSub. But the unique thing about Cloud IoT Core is that it's also meant for talking back, and it's specifically meant for devices. So this is something that can run with any hardware that your city's bringing along, any sensor or actuator, over a number of different protocols. MQTT is a lightweight protocol for devices that are a bit more resource constrained. HTTP for something that has a bit more compute power and overhead and doesn't need quite that. But this is a way for you to give your devices a unique identity and be able to talk back and forth with them and tie them into the rest of the GCP ecosystem so you can start making use of their data. And we're going to talk a bit more about the rest of this picture of what does making use of their data look like just in a minute. But what we're looking at here is a bit of add these blocks together and we can start playing with the ideas that we were looking at in a couple slides earlier. All right, let's take a look at a couple more adjectives. Responsive. So responsive seems self-evident. You would want a smart city to be one that can correct if something's going wrong, something that's aware of what's happening in its own grounds, and something that feels like it's not just operating on autopilot. What's an example of something responsive? Well, here's an example of something that we've learned a bit from at Google, and this is a parking feature that we've rolled out, which is based entirely on machine learning. This isn't the same level of granularity as what John's about to talk to us about in a minute. This is just high level. This is just a bit of information on where people are sometimes and trying to make some estimations on traffic patterns and parking patterns based on that. So if I'm planning a trip to the mall or I'm going to a city I've never been to, I can get a bit of an idea of, hey, it looks like I should go at 10 a.m. instead of 4 p.m. And this is an example of something that doesn't just show you where the parking lots are, it's responsive to when you might want to be there. What's another adjective? Self-aware. So this is one that I find really interesting and really important in the smart city space. And it's core to rolling out any new programs as a municipality, or it's core to being a vendor to the cities because you can't make good decisions unless you know what's going on in your own grounds. What does self-aware look like for a city? Well, a lot of you, I bet, have used Street View before. I was just doing a trip last weekend and had never been south on Highway 1 before and was using Street View to check out a couple of towns and where's a nice spot for a hotel. So that's an example of how I can get a bit of an awareness as a consumer. But one thing that we learned at Google from Street View was the incredible richness of image data. And this picture that we're looking at was useful to me as somebody taking a ride, but how could it be useful to a city? You might also be familiar with Google Lens as a consumer, something else that makes a bit of intelligence from images. This is an example of, I take a picture of a flower, I can have that flower identified for me. It was something that rolled out at a recent I.O. and is chasing that exact same problem of, well, we've got a lot of image data out in cities these days. Is there anything we can do with that? So this is a consumer example. What might that look like in a smart city context? How can I take these adjectives, responsive and self-aware, and look at some Google tools that would let me chase that would let me learn from that? So I'm pretty excited to be able to chat about this one today, as it's a relatively new idea that some of our teams have been playing around with. And it's a combination between some of our learnings from Street View and our machine learning and image processing tools, and the GCP tools that are offered publicly. So none of this is you have to ask for special permission. This is all GCP tool capabilities. But it's an idea that we're looking actively for early partners on. So if it looks like something that's interesting to you, reach out to me after the talk. Geno Lens is the consumer product. It will take an image and tell you a rough idea of what's in the image. What you might also know is that inside GCP, there are a couple image processing tools that go deeper than that. The Vision API is effectively that for your apps. If you're building something that has a photo capability, you can send the image to the Cloud Vision API, and it will return with a level of confidence what it thinks is in that image. And that's great for a lot of use cases. If you want to be able to tell, yeah, this is a car, or this is a park, or this is a tree, it's an incredibly powerful thing to build in with absolute simplicity to an app. But what if I wanted to go one level deeper? What if a city really wanted to get to know what's going on its grounds without having to kit out an enormous sensor network? Well, let's go one level deeper to the next product called AutoML. And this is where you can start training your own image recognition models. So this starts to get really powerful as cities start wanting to ask questions about what's going on our grounds. Now, our own Street View imagery isn't publicly available and isn't available to process for a number of privacy reasons, but images that a city is taking itself are well within their right to process. So what might it look like to take a look for, are there trees close to power lines that might be a risk right now? Are there potholes in the road that we might need to be keeping track of? These two products are built for exactly that. Cloud Vision API gives you a good idea of what's in a picture and is dead simple to integrate to your applications. You pass it an image, it passes back what it thinks is in that image. But if you want to go one level deeper, and you're working on an application for a city that says, we'd love to help you answer a very specific problem, then Cloud AutoML will let you very simply, without a data scientist on your team, create new models that will allow you to identify what you're looking for. So imagine what this could do for cities. If you could get a better idea of real estate value out of images, if you could take a look at where are we at risk for a tree falling on a line, where are we looking promising for new areas of growth based on businesses and buildings that are booming in that area? An idea of, could we look for indicators of energy surge of production? Could we look for measures quantitatively of development, of poverty, of living conditions in our cities? These are tools that are on GCP today. So we've talked a bit about a couple of the projects that we're working on at Google, and we've talked a bit about what we learned from them, and what are some of the GCP tools that might help you ask those same questions in your cities. But let's go one level deeper. Imagine if you were never stuck looking for parking. And to answer that question, please join me in welcoming up John.
Thanks, Fraser. Yeah, we're living in a changing world, aren't we? And parking is one of the things that we live with, which really sucks. And so I just want to tell you a little bit about who we are and what we've been doing for now 15 years. We've had to build a lot of technology ourselves because there are no standards, but we're doing it in the real world every day today. So we're based out of several locations around the world, Australia, New Zealand, and the UK. We actually dog food our own technology in the UK, and we run hundreds and hundreds of car parks across the UK with our own technology. But in New Zealand, in Australia, and other parts of the world, we have a number of very significant smart parking systems in place. Tens of thousands of sensors. We build sensors that go in the ground, just like that. That's just an example of one. It's not much bigger than a D-sized battery, and it has to last for up to 10 years in the ground. So that's the sort of things that we do. So we've had to do hardware, we've had to do software, we have to do the networking, etc. And it's all powered today on Google Cloud Platform. So this is just a quick list of some of the cities that today are using the smart parking solution. And we're starting, this is still a journey in progress. You know, a lot of the things that we're doing are still just the very basics of just show me where a car park is, you know, tell the city or the business how the parking is used. You know, is it being used efficiently and effectively and continuously, or is it underused, or is it overused? Is the pricing right? Are the types of rules, such as how much time you're allowed to park in a certain parking spot, actually appropriate, etc. So these are just some of the cities that we're running today. And the big question that we're starting to pose is, what about your city? So today, we already, you know, as you can appreciate, we've had to build a comprehensive range of solutions. And this diagram just illustrates some of the types of functionality targets or audiences that this technology delivers to. First of all, the person in the car driving. We deliver a broad range of applications which give guidance and information about parking spaces. It's using Google Maps, using Street View, all that sort of interactivity, that convenience, that connection with you, and so that you understand what's actually happening and where you're going. And then finally being able to actually pay for that parking session, whether it be a pay for what you use, so you know a timer starts to just tick away the time, and when you've finished your car parking session and you drive away, it closes that session. We do that today. Or you know, it can be a fixed, you know, prepaid, you know, you pay for 20 minutes or pay for 30 minutes or whatever. So that's one class of application that we are delivering. And just last week, we delivered two new versions of that application to customers in other cities. The enforcement officer, you know, I know, you know, this is probably the least desirable aspect of parking, but there are people that need to actually go along the streets and effectively and efficiently manage where the cars that are just not playing by the rules, right? And do the necessary thing of putting a ticket on your window. Now, what we give is live, real-time information to those officers on the street, telling them exactly where the car is, exactly how much they paid, when did it expire, et cetera, et cetera, et cetera. So, and this is real-time information. A lot of what Fraser was just talking about is about being alive. The city is alive, and these sort of things need to be constantly moving. Talking about IoT, one of the things that we have found, well, is a necessity of parking, is that this is actually legally enforceable IoT. As you will well know, as being drivers, and you know, you've ridden in cars and parked in cars, we all have, right? A car can actually leave a parking space and another one pull in right away, right? And we're talking about within the second, assuming you're not speeding too fast. But it happens really, really fast. And if we didn't detect when that new car comes in, we could give a parking ticket to that second arrival. We can't allow that. And this is actually the rigor and the significance of the class of IoT that parking is. Now also, as I commented before, this is a battery-operated thing, and it has to last for years. But meanwhile, we're doing this real-time communications. We bury it in the ground, and it's usually in concrete or tarmac, cement, and so on. It's very, very nasty for radio communications. We've had to develop that type of radio communications. And then finally, we put big metal things over the top of it, right? Which also gets in the way of doing reliable, secure, robust radio communications. And so these are the sort of, this is the class, the edge of IoT that parking is all about, and smart parking has solved. And I can tell you, you know, we've got a lot of wounds on our backs, a lot of scars from learning this technology. And in fact, as I commented, you know, dog fooding our own technology has been a really, really good way to make sure that we do the right thing. What has actually started to come back to us from our customers, you know, from those cities, from those customers who are utilizing our smart parking platform, is once they put those gateways, those communication gateways onto their lampposts, right, getting power and network connectivity to them either through 3G, 4G, or some sort of other communications mechanisms, that gateway becomes a very strategic element for building out more sensing and more capability into the smart city infrastructure and the solutions that a city wants to actually deliver. And so what we've been actually being told by our customers, and we're responding to, is building an open platform, an open framework, which enables smart cities. And so it's not just about parking, it's actually about modern life in cities, pretty much as Fraser and I are talking about now. And where this is taking us is actually into building a broad range of solutions that sit on top of the smart cloud platform, which is completely GCP. It's actually 100% pure serverless as well. There is no Linux operating system in it. There is no Windows operating system in it. It is completely built utilizing GCP serverless computing components. And this is really exciting because I believe this is actually the future for how we build large-scale, internet-scale, global-scale, live network computing systems, which is essentially what I'm going to talk about here. Now, the first building block that we utilized was the cloud Core IoT functionality that Google provided. And we did this, we started using it around about 2 years ago. Prior to that, we'd actually been building our own IoT framework for managing our devices. But as we were listening to our customers and seeing the need for smart cities, we needed an open IoT framework. And it just did not make sense to reinvent that wheel, especially when you had solid serverless technology that was also going to be driven by the market, that was going to be open and flexible, that our team didn't need to rebuild. We didn't even need to support it. We don't need to now maintain that technology. And we can trust that GCP and Google are going to drive that more and more into the functionality requirements of the market, and we just are able to benefit from it. And as I commented before, this is actually giving us city-scale live responsiveness. We are doing today, with those cities that I listed before, in the order of about 1.5 million to 2 million sensor event transactions per day. What you might not have noticed also on that slide, that previous one, that diagram, was we also do cameras. Especially in the UK, we do a lot of number plate recognition. And we're doing about 1 million images per week. And so that's the class of computing, the capacity of data that we're processing through this platform called Smart Cloud. The following three things that I talk about here is one of the objectives of our Smart Cloud platform was to actually eliminate the need to have software developers involved in everything that a customer wants. We wanted to enable the customer to build their own dashboards, their live dashboards, to display them anywhere that they needed to, without requiring us to go and hack some code. The same is true for data analytics and data processing. And what we have actually done is we've used BigQuery and Data Studio, which is a fantastic tool. My analogy is, Gmail to email is Data Studio to big data. It's actually that. It's free, like Gmail is. It's an amazing tool, and I'll show you in a moment just some displays of those sort of reports that we're generating directly from Smart Cloud, which is using BigQuery underneath it. The same is true for business rules. Now, for parking, there are very complex processes for managing business rules. Time of day when parking can occur for certain types of uses of that parking. When is enforcement being enabled and when is it not? Certain car parking spaces may become non-car parking spaces, let's say at 4:30, to allow traffic flow. All those rules, including also other things such as, has a payment arrived? Have they overstayed their welcome in that parking space because they've gone beyond the maximum period you're allowed to park? So all those business rules, which historically we wrote custom code into the system and had some sort of a UI that you'd type in some data, typically into a database. Now what we have is an if this then that rules engine which processes this continuously. And I mentioned our mobile apps for guidance and payments and other things. In fact, the app area is just so significant, and we're all users of apps. What we also realized was that you just don't want to have yet another app, and there are a number of surveys that have already shown that after 90 days or so of getting a smartphone, you typically don't load another app. So getting that footprint onto your phone is really, really hard. And so what we've built is an app framework. Obviously, we have full functional apps. A smart parking app on the app stores today is our app. And a number of cities that I listed there have taken that app, and we've actually branded it and facilitated it with functions that is appropriate for them. But more interestingly is taking those components, such as the guidance component or the payment component, and embedding it in your own app. And so that's the framework for mobile apps that we've also developed. And finally, managed APIs. APIs is actually how you integrate, how you enable innovation with ourselves internally, how you work with partners and software vendors, as well as integration with city systems, and so a full suite of managed APIs, which are, in fact, is using the Apogee technology from Google Cloud. Guess what? So, just want to quickly now show you, if we can switch to the demo. Yay! I must admit, we had a little bit of a network issue as I sort of walked up. But here's a live picture of one of the cities. It's actually Wellington City, the capital of New Zealand. So one end of the world. And what we've got here is, I'm zooming into the city. These are the parking bays that are around the city of Wellington. And I can see that that's been vacant for 38 minutes. This is live data right from the city, right? And this is just one aspect of visualization. And because it's built into dashboards, I can do such things as I push it into full screen mode and display, you can put it onto big screens elsewhere. Every one of these dashboards is just a URL. And one of the powerful things is I can create my own dashboards, and there are some default ones. There's the data. The smart zone is what we call our infrastructure area, where we can monitor and see the infrastructure. And what you saw earlier on in Fraser's slide is that sort of map of the city's activities going on. Well, here what we've got on one of the other, what we call tiles, is actually a 24-hour cycle of the heat map of the parking utilization in the city. And this is just another bit of insight that we're providing cities. Now, if you notice, just some of the things to prove this is real time, you can see the numbers changing there. Those are parking events that are happening on the other side of the world right now. Here's another city. This is Hamilton City in New Zealand as well. And I think I've lost the other ones. I was going to also show a couple other cities like Cardiff and so on. So can we go back to our slides? So just going back to those sort of smart city requirements, one of the things that we in smart parking and in the smart parking solution have to respond to, and pretty much what Fraser was talking about, is this live streaming, this constant, this instantaneous world that we live in. And this is a change for how computing needs to be done. It's no longer store something into a database, then retrieve it, do some sort of processing on it, produce a report, and then store it back into a database, etc. Things have to be instantaneous and responsive. For example, if you were driving down the street and you were using Google Maps and it took 20 seconds to sort of give you the next turn, you'll probably be on the wrong street, up a tree, or something like that. So this is the new norm, is live streaming. The efficiency and convenience. I've been talking, just indicated the things like apps that we are delivering, the dashboards, providing those dashboards to any display, whether it be a display on a street, because it's a URL, anywhere there's a browser, that can be displayed. And one of the experiments that we're actually working through is just using Android things, to display that in remote places onto other displays. And this is really great for just providing that convenience of information where it's pertinent. And a dashboard can be just, for example, how many bays are in this area of a street or on this floor of a parking building. And so this is all about connecting insights to you. And the you I mean here is there are many different audiences. It can be you, the user of parking, but it may also be the city strategist who wants to have understanding of what's actually really going on. Are the uses and mechanisms that are being operated for the parking, is it optimal for the city? As we all know, it becomes very, very inconvenient and challenging when you're circling round and round blocks just trying to find that park. Now, using this real-time data, accurate data, we can take you right to that park. And when it changes, we're letting you know as well. What we're doing is we're starting to create the ability to enable new outcomes. And we've done that both on the technology. So rather than using classical computing, and I actually class using standard traditional servers and server OSs as being classical, we've gone completely serverless, completely what I call cloud native for this platform. It's essentially the same way that Gmail works, the same way that Google Search works, is how we've built Smart Cloud, our platform. And it's enabling ourselves and also our customers to actually achieve new outcomes. And this is driving us to become more responsive with our roadmap. A roadmap is no longer a 12-month roadmap. It's actually dynamic and changing because the way we're implementing the functionality and the way we're enabling our customers to also have their roadmaps of functionality is in a much more agile and a much more modular and freed, democratized manner. Democratized is an overused word, I think, in this conference. So here's just a quick view of the architecture of Smart Cloud. And as you can see, it's heavily GCP. And it's, as I mentioned, totally serverless. So IoT Core is where we ingest and we send out messages from, and we also manage these tens and tens of thousands of devices, both the gateways and the sensors that are actually in the streets or in the parking buildings. I don't know if you've been to parking buildings where you see the red-green lights over parking bays. It's quite common in some parts of the world. Certainly, it's very popular in Australasia. And it changes the whole dynamic. You drive into your parking building, and you literally will just glance out of the periphery of your vision to see a parking spot. And and then we put signs throughout, just saying, okay, there are 5 up on level 4, and there are 12 up on level 5, and so on. And also just being able to glance out of the site. So this sort of information is all being managed by IoT Core, both the measurement and also the control of those indicators, for example. We're also managing the data in very dynamic ways. I talked about using BigQuery as the fundamental core for big data, but simultaneously we're using BigTable, which is essentially the engine underneath Google Search, to also manage those parking events in real time. And then the APIs I commented about for dashboards, for payments, and actually any application. So, over to you now. Hopefully that's given you a taste of what we do. The point is that what we're doing is real-world IoT that is trying to, and is actually reinventing the experience for cities already.